Now, the second type of calculation involves from the known value of percentages, you need to uh, calculate the value of the original variable x. Again, three steps are involved. First, you need to determine what is the appropriate percentage to use. Sometimes the question gives you a percentage, but that percentage may not be directly what you need to use to look up a normal table. So you need to do a little bit calculation. Okay. Then after you find the correct percentage, you would go to a normal table to find the corresponding z-score. After that, you apply this formula to calculate the needed value of the variable x. As we said before, this formula is derived from the z-score formula. Question 8. A case has a standard score, which is g-score negative 1.4. What is the raw score, which we mean the value of variable x for the case? Now, this is a question that does not involve looking up a normal table. This question is just a practice for you to get used to apply the formula to calculate the value of x from this z-score. Now, in this distribution here, the distribution of z-score, we know that from the question we have a z-score negative 1.4, and this is a value to the left of the mean. Okay, and we know that all the values in a variable x can be converted to a z-score, and this is original variable distribution. When you convert all variable values of x into a z-score, this is a resultant distribution of z-score. What we know now here is that we know the converted value. After we convert the value of x into a z-score, the z-score is negative 1.4. How do we obtain the original score for variable x? So that is the question. We know the formula we use to do the calculation. So that is, we need to use that formula to calculate the original value of variable x that correspond to a z-score negative 1.4. Okay. The formula we use is this one. Okay. So this formula tells us that to obtain the value of original variable x, you need to use the population mean plus z-score times standard deviation. Okay. We know the mean is 78, standard deviation 6.3. All we need to know now is z-score, but z-score in this question is given. You do not need to look up a normal table to find what is z-score. The z-score is already given to you. So what you need to do is plug in all the numbers into the formula to complete the calculation. So we bring this negative 1.4 into the formula, complete the calculation. So we know that the value of variable x that correspond to a z-score negative 1.4 is 49.18. Okay. So this is a question just let you to practice how to calculate the value of original variable. Question number 9. Between the mean and the worst scores are there 25% of cases. Okay, let's draw this diagram here. We know that the mean 78 here is in the middle. if you have interval 25% on either side, and then you have this 25% on either side. The question is, what is this lower value x and the upper value x? In between, you have in total 50%. On either side, you have 25%. Okay. Obviously, normal distribution is a symmetrical distribution. You know the value on this side, on the positive side. You kind of know the value on the negative side. Now let's do the calculation. Now we know that we are given the percentages. We're given the percentage. Okay. Question is that given this percentage, what is the z-score that corresponds to 25%? So what is the z-score that corresponds to 25% here? Also, what is the z-score that corresponds to 25% here in upper bound? If we know the z-score that corresponds to this value and this value, we can use the formula that we used from the previous question to calculate the value of the original variable x. And for that reason, we need to go to look up the normal distribution table to find out what a z-score corresponds to 25% here or 25% here. Either way, because this is a symmetrical distribution, we know the positive side, we would also know the negative side. Now let's go to the normal distribution table. We know that within this field, the lot of percentages, the percentage that we need now is 25%. Okay, we need to find within this table a percentage that is 25%. But here you can find that this value is 2486, not quite 25%. This value is 25.817, is more than 25%. So 25% is somewhere here in between. So what you have to do here is that you pick either one. You can use 2486 or 2517. You use either one will be okay. Okay, so and there's a little bit subjectivity here. So you probably decide to use this value, and the other student may decide to use this value. So the result of calculation from two students may not be exactly the same because you choose to use a different percentages here. So let's decide that we use this. Let me see which one I used. I obviously use this value. Okay, so let's decide we use this value. If we use these percentages, let's see what is the corresponding z-score here. 2486, and you will read on this side. Okay, the first column gave us 0.6. Now you read across, come to this point. On the top is 0.07, so 0.67. The z-score that corresponds to this percentage is 0.67. Okay. Now come back to the question. From the normal table, we find that corresponding z-score, the z-score that corresponds to 25% here is 0.67. Okay. As a result, we bring in that z-score into the formula to calculate this x value. So x value is, using this formula, mean plus z-score times standard deviation. The mean is 78, z-score is 0.67, which we just find out from the normal table. The standard deviation 6.3. The result is 82.22. So this 82.22. Yeah. So this value This value should be 82.22. Okay. What about the other x value here? Okay. This value at the lower bound, x value at the lower bound, can be calculated using a similar formula. Okay. Same formula. Okay. Mean plus z-square times standard deviation. Now, what you have to pay attention to here is that when you bring the z-score into the formula, the z-score is negative 0.67. Why negative? Because we know that for this x value, it is below the mean. Whenever this x value is below the mean, the corresponding z-score should be a negative number. So for this question, we look up the normal table, find out z-score 0.67. But for the side of distribution that is above the mean, we bring positive 0.67 into the calculation. Now for the side where it is below the mean, we bring negative 0.7 into the calculation. And this is very important. Okay. And after you complete the calculation, you obtain a value 73.78. Now, the way to check this question is very, the way to check this result is very easy. Okay. This value is below the mean, so it has to be smaller than 78, and give us the result 73.78. But this side is above the mean, so it has to be larger than 78. It turned out that it is 82.22. So the lower bound is 73.78. The upper bound is 82.22. So that's answer to question number 9. Question number 10. Below what score lies the smallest 20% of cases in the distribution? Okay. Now let's draw this diagram to make sure what the question is asking. We have this distribution and with a mean 78. The smallest 20% cases obviously have to be located to the left corner of the distribution. So that means that corner is 20%. Within that corner, you have 20% of cases. So from this point to the left, you have 20 smaller is the 20% cases in the entire distribution. The question is, what is the score that's right here, below which you have this 20% of smallest value? So what is that value? Okay. Now, obviously, we need to, this is a question, we know the percentage. We need to figure out the value of the original variable x. To do this, we need to find out the corresponding z-score. The z-score that corresponds to this value x. Now you may just rush to the normal table to find out, okay, what is the percentage that what is the z-score that corresponds to 20%? You may just rush to the normal table to do just that. Now you cannot do that. You cannot do that right now, because let me show you this table again. One more time, we'll emphasize this fact. Look at the heading of this table. This table is made in such a way that the percentages in the field in the table reflect the shaded area from the middle outward to a particular z-score. Okay, so all the percentages here show the area in is the shaded area here, not the corner. But this question, the question, the 20% is a corner. 20% is a corner. You won't find any percentage number. You won't find any percentage number in this table that show the size of a corner. See, those are values here, not the size of corner. Those values here are these slides. So this question, you simply cannot take this 20% to a normal table to find z-score that correspond to 20%, because that table does not show you the size of the corner. If you use a different table, that's a different matter. But right now, if you are using this table, you cannot use that 20% on that table. What we can do? Well, in that table, the percentage shows the size of the slices from the middle of a distribution to a z-score. It shows the slice. This is the slice. This is the slice. So we need to know the size of this slice, and therefore, based upon the size of this slice, we can find the z-score that corresponds to this x value. So what is the size of this slice? That is easy to find out, right? The half of the distribution is 50%, so simply subtract 20% from 50% and to obtain 30%. And now we know that this slice is 30%. Now we are ready to take this 30% to the normal table to find the corresponding z-score here. Let's do that. Okay. Now let's look for a value closest to 30%. Now you have this question of which one to use. You have a value 29, 97, 95, and 30, 23. So you can use either one. Let's use this one. So if you decide to use this one, the corresponding z-score will be 0.84. 0.84. Okay, that might be what I use here. Okay, let's come here. From the normal table, we find the corresponding z-score. We find the z-score that corresponds to 30%. Okay, is 0.84. Now we bring this z-score into this formula to complete the calculation. Okay. Now again, why I have this negative sign here? We find the z-score from the table is 0.84, but you have to remember that if this x value is below the mean, from this diagram, it's obvious it's below the mean, below 78. Therefore, for the corresponding z-score, you need to add a negative sign here when you bring it into the calculation. So 78 plus negative 0.84 times standard deviation 6.3. That gives us 72.71. So this x value is 72.71. So that's the answer to this question.